Godot doesn't have toon shaders that resemble what you see in anime games like Guilty Gear or Naruto. Godot doesn't have toon shaders that resemble what you see in anime games like Guilty Gear or Naruto. It does have a toon shadow option that shifts gradient shading into linear shading, but that's how further it goes. There are various custom-made add-ons, but neither is up to par with how engines like Unity and Unreal handle toon textures. After intensively studying how Godot shaders work, after intensively studying how toon shader works in Godot, how toon shading works in Blender, and how it works in other games, I have prepared this toon shader for overall usage in Godot to make your characters look straight out of Guilty Gear. That being said, there isn't an end-all be-all solution for toon shader. Many games have different takes how the characters look, so this shader might not necessarily be useful to you if you want to make something that resembles a manga or a comic book. But if you want your character looking like a Guilty Gear character, or you want something similar to it, you're at the right place. Well, my goal was to make a shader that Godot developers can easily use. This shader and NPR as a whole has a learning curve that I will try to explain here. In this video, you will learn how cartoon shading works in Godot, how to use my shader to give your character cartoon looks, how to make your own custom shader cartoon. In this video, you will learn how cartoon shading works in Godot, how to use my shader to make your own characters look cartoon, how to make your own custom cartoon shader using the one I made as base. So this video will be divided into 3 parts. First, we'll start with a basic explanation on the drawbacks of NPR and cartoon shading in general in Godot, how to make a cartoon shader from scratch, and a quick guide on how to use the one we made on characters. Feel free to skip the video whatever part you find more interesting to you. You can find a free version of this toon shader on Godot shaders. Extra features like specular textures, and various characters that use the shader will be available in my itch.io page in the description. So without further ado, let's get started. Now, for one of the caveats of NPR as a whole in Godot is that the heavy lifting isn't actually done by the shader or Godot itself. The difficulty relies on the systems used to make these characters handcrafted. To make these models look how they should look, they have to be tailor-made. And that's going to depend on where you model the character. If you're using Blender or any other 3D modeling software, I have a NPR shader working over there, but that's going to depend on where you model the character. If you're using Blender, I have an NPR shading over there in the description for you to use. So regardless of where you make the models, you will need custom normals, custom UVs, high-resolution textures, high polygeometry, maybe vertex colors, and all of this cannot be done in Godot. You need Blender or other 3D programs. Thankfully, yours truly has made a guide on recreating NPR shading in Blender, so please check it out if you have no idea how NPR characters work. Be aware also that there isn't a shader that does everything for you, because it really can't. It relies a lot on the mesh. NPR relies a lot on its mesh. So with that out of the way, let's start the tutorial inside Godot. Okay, so we make a new scene. We add a test mesh. We'll use a sphere, create the shader file, search for shader and name it Celltoon Shader. Open the shader, double click on it to open Godot's shader code editor. Apply it to your 3D mesh. Select your character mesh in the 3D viewport. In the inspector, over the right panel, open geometry, right arrow, material overlay, or the mesh surface materials. Click on the drop down right arrow, new shader material, drag and drop your Celltoon GD shader into the shader slot, and there we go. Our shader is implemented, but it's empty. Now step 2, at the very top of your shader, we're going to define what kind of shader this is and what knobs and sliders you want exposed in the inspector. Yes, we will be doing our shader in text form. You can make it using visual shaders, but I find it to be more complicated than using text. As first in text, you just write, or you just copy my text, copy my script and paste it, much easier. So anyway, at the very top of our shader, we're going to define what kind of shader this is and what knobs and sliders we want exposed in our inspector. I'm gonna set shader type spatial, render node unshaded. Why render node unshaded? Godot has a built-in realistic lighting engine. So by declaring unshaded, we will tell Godot, turn off your stupid default lighting. I want to calculate every shadow and highlight manually by hand, okay? We're gonna set the uniforms. These are going to be the on and off toggles. Uniform bool, as in on and off. Use shadows, I'm gonna state that is by default true. Specular highlights, also true. Rim lights, also true. Use automated black lines, also true. We will change this later, but for now, let's leave it like that. Okay, the texture slots. This is where we're going to put our characters' textures. You're going to create a uniform, sample 2D, a 2D texture. We're gonna call it body texture, and it's gonna be equal to source color filter linear MIP map. Same for the shadow mask. This one will by default black, also linear MIP map, and a specular mask texture, which will default would be white. Light direction. This is where we set where does the light come from. We're gonna put this over here. I recommend you set it to 0, 0, 0. This is going to be manually edited by a sphere that we're going to add, which we can later rotate and set the light direction. For now, you're gonna leave it like that. Shadow parameters. We're gonna have 3 uniforms. One is going to be a vector 4, which is going to be our shadow tint color. This is going to be the color of the shadows. And I will say as a pure magenta. Shadow multiply color. It's a factor where how much the multiply of the shadow mask will be. We also make a float for the shadow size. It controls how big the shadows are. The bigger the shadow, the more the shadow will opaque the whole body. The smaller, the less it will opaque its whole body. By default, it will be just 0. Half lit, half unlit. Specular highlight parameters. With this, we will set the parameters of the specular lights, their size, and the specular highlight color. We're also going to add an extra. Also, I forgot something. We're going to add an additional texture that's going to be instead of specular body. We have a body, we have a shadow, specular. I'm going to add a rim. This will be by default black. All of them should be by default black. Light direction, shadow parameters. This will set the parameters for the shadow. We have our tint color. We have a multiply range. And a shadow size. Already said that, but specular highlight parameters. We have a size, how big the specular highlights will be, and a color, and a default color. Okay, body fragment. Inside the body fragment option there, we're going to find the direction of the light. The first thing we must do is find our bearings in the 3D world of space. Now, where's the surface pointing at? Where's the surface normals? What's the direction of the surface normals? So the word normal is going to be this mat as a view matrix. This will set what direction is the surface pointing at, and where is the zone pointing at. We will use a sphere normal. Then we have the view direction. We're going to sample our body texture. Going to do our main shadow calculations. Not make the shadow mask also take the colors of the shadows. You can, but it complicates things. I don't see that necessary. Even I find color rim lights to be not to be that useful. You know, that's the best I can achieve. So yeah, guys, that's it. I did. Like and subscribe. Bye.